All right, the 2017 AB free response question number 6. This was a non-calculator question. Given a lot of information, we have a table for G, a graph for H, and an equation for F. They do tell you that G is differentiable, and they tell you that H consists of 5 line segments. And so question A, find the slope of the line tangent at x equals pi, just means find f prime of pi. So to do that, first we need to establish what the derivative is. This is a chain rule. This one's fairly straightforward. F prime of x is going to be, the derivative of cosine is negative sine 2x times the derivative of the inside, so I'll stick a 2 in front, plus, and the derivative of e to the sine x is e to the sine x times the derivative of sine, so it'll be cosine x times e to the sine x. And then we could plug pi into that, so f prime of pi is going to be negative 2 sine of 2 pi plus the cosine of pi times e to the sine of pi, and you are allowed to stop right there. However, this one does clean up nicely. Sine of 2 pi is 0, cosine of pi is negative 1, and sine of pi is 0. And so you end up with an answer of just negative 1, but that is not worth anything more than you would have gotten if you just left it in terms of sine and cosine. So there's part A. Part B, same type question. Here's a function, find its derivative at pi. This one, we're going to have to do the chain rule. So k prime. I think this should be easy because it is the very definition of the chain rule, but some people are kind of put off by the weird presentation, not having an actual equation for h. So h prime of f of x times the derivative of the inside, f prime of x. And then we'll plug pi into that. K prime of pi would be forgot my equal sign, h prime of f of pi times f prime of pi. And here we get a little bit lucky because f prime of pi was our answer to part A. And so at this point, if I hadn't already simplified the problem, I would go on and simplify it. So this negative 1 is going to come in handy. So this will be h prime of, I haven't done that part yet. I need to find f of pi. And then f prime of pi was negative 1. So now f of pi. So let's go up here. F of pi is going to be the cosine of 2 pi plus e to the sine pi. So cosine of 2 pi is 1, e to the 0, which will end up being 2. So this is h prime of 2. Now I got to get h prime of 2, and h was presented as a graph. So h prime of 2 means find 2 on the graph of h and measure that slope. That is a line with a slope of negative 1/3. So then this answer finally ends up being negative 1/3 times negative 1. And again, you can stop there, or you could turn it into 1/3. Go on to C, almost the same type question, or it is the same type question. Here's a function m, find m prime of 2. So we're going to have to do the derivative of m. So m prime of x, this is a product rule, and g of negative 2x is a chain. So when I do the derivative of the first function, that's going to be g prime, negative 2x, times the derivative of the inside, negative 2. Leave the h alone, plus leave the g alone, times the derivative of the h, which is just h prime of x. We will plug in 2. So I'll be g prime of negative 4 times negative 2 times h of 2 plus g of negative 4, h prime of 2. The g values are going to be easy because there is a table that explicitly gives you those values. So g of negative 4 is 5, g prime is negative 1. So I'm going to start plugging those in down here. G prime, what did I say? Negative 1. So we have negative 1 times negative 2. H of 2, I'm going to come back to that in just a second. G of negative 4 was 5. And h prime of 2 is what we did just a minute ago. That was negative 1/3. And so now I need h of 2. And because h is a line, we are not going to estimate that. You can find that exact point. Trying to think of what okay. So I can't decide how I want to do this. So one way, and it does take a little bit longer, would be to find the actual equation of that section of h. So right here, I already know that the slope of that line is negative 1/3. And I can look at this piece and I can actually see that the y-intercept of that segment is 0. And so I could write this as negative 1/3 x plus 0. And then if I want to know h of 2, that would be negative 1/3 times 2 plus 0, or negative 2/3. So you can get that exact value. You could also kind of think, if the slope is negative 1, excuse me, my slope is negative 1/3, then for every 1 I go to the right, I go down 1/3. So if I go to the right another 1, I'll go down another 1/3, which would be going down a total of 2/3. So that's another way you can kind of think of it. I'm going to stop right there with m prime of 2. If you want to clean that up, you can. You can check in the calculator, see if you are correct. Okay, then finally, part D. Is there a number C on the interval -5 to -3 such that g prime equals -4? Okay, so there are 2 ways to try to do this one. So we're focusing only on the function g this time. Because I actually have a column of values for g prime, I'm going to look and see, is there a time from -5 to -3 that g prime must cross -4 by the intermediate value theorem? In other words, does g go from one side of -4 to the other side? And unfortunately, we don't. We're all greater than -4. So intermediate value theorem fails. And so the second approach, and this is usually my first thought when I'm asked for values of the derivative, my next approach is to try to use the mean value theorem. Because the mean value theorem says that if a function is differentiable, which they do tell you g is differentiable, then there must be a point where the derivative is equal to the slope from beginning to end of some interval. And since they mentioned the interval -5 to -3, that's what I'm going to go for here. So I'm going to start by using I'm going to use the mean value theorem. And anytime you use a theorem, you must establish the conditions that allow you to use that theorem. And so I'm going to start off with saying that g of x is differentiable, even though they already said that in the paragraph. I'm also going to establish that g is continuous. In 2019, I graded AP exams, and there was a mean value theorem question on the AP exam. And if they did not say that the function was continuous, they lost a point. So I know that differentiability does imply continuity. However, in 2019, you actually had to write the word continuous somewhere in your work. So make sure you do that. So g is differentiable and continuous. Therefore, the mean value theorem guarantees that g prime of c is equal to, and I'm going to go ahead and write this, although I should give a little bit of thought before I write this. G of -3 minus g of -5 over -3 minus -5. And the thought I should get this is, will this actually give me an answer of -4? I'm hoping I get -4. And so 4, Oh, I'm sorry, I'm looking at the wrong table of values. Whoops, I was looking at g prime. Okay, remember, we're doing g, not g prime. So we're going to use the mean value theorem here. Whoa, geez, what's going on? Let's undo that. So I'm going to use the mean value theorem on these values. And if I do g of -3 minus g of -5, that's 2 minus 10. That's going to be -8. -3 minus -5 is +2. negative 8 over 2 will give me the negative 4 I want. So I probably should have just thought about that real quick before I wrote down this fraction, because if this one failed, then you may actually need to try maybe negative 4 to negative 3 or negative 5 to negative 4. Sometimes you have to fish around within the interval that they specify to find the slope that's needed. More often than not, if you use the endpoints that they provide on the interval, that will work, and this is no exception to that. So g of negative 3 was 2. G of negative 5 was 10. Negative 3 minus a negative 5 will be 2. And so that's negative 8 over 2. That does give me a value of negative 4. And that is my justification. I cited the theorem, I established its conditions, and then I worked out that theorem. So we are now done with part B.